Hello friends, our today's question is candy. So what is basically given in this question is we are having n children standing in a line and each children is assigned a rating value given an integer array ratings. So we are given an integer array ratings where rating for each children is given. So we have to give the candies to the children subjected to the following requirement. So we have to give candies to the children on the basis of the following requirement. So the first requirement is each child must have at least one candy. Okay, so like every child should have at least minimum one candy, and a child with higher rating get more candy than their neighbor. So this is the second requirement, that the child having more rating than the neighbor should have the higher rating, higher number of candies. So what we have to return the minimum number of candies. You need to have to distribute the candies to children. Okay, so considering these two situations, providing candies on the basis of these two situations, we have to return the minimum number of candies that will be required to distribute the candies among the children. Okay, so we have given the caution also, like ratings 0 1 2, and output is 5. So 5 candies are required for the above rating, uh, above rating of the children. Okay, so how they have allocated? So you can allocate to the first, second and third child with 2 1 and 2 candies respectively. Okay, so now looking at this example. Okay, so we are given an integer array ratings. So what is the rating? 0 1 2. So what they have mentioned, first condition they have mentioned at least one candy, and second condition they have mentioned is uh, higher candy than neighbor. Okay, so we have two conditions. The first condition, at least one candy, and second is higher candy than the neighbor. Okay, so what they have done is now, like, okay, so they are so for like we can have this an array equals to the size of the rating. So basically each child will have minimum of one candy. Okay, so now we have to check, like, at least one candy, this condition is fulfilled. Now we have to check the second condition, higher candy than neighbor. The neighbor spelling is wrong, never mind. Okay, so the first or the zero index child is having candy higher than its neighbor, so its candy should be higher than the neighbor, so it candy should be 2, because as we have to give the minimum candy, the higher number of candies can be any, but the answer we have to return is the minimum number of candies that we can provide to these children according to their ratings. Okay, so here it will have one candy, so 1 plus 1, 2 candies it will have. Now to this one, this is not higher or greater than the neighbor. Okay, and for this one 2, the last one, it is greater than its neighbor 0, so it will also have higher candy, so it will be 2. Okay, so total number of candies required by this is 5. Okay, now if we look for the second example, that is 1 2 2. Okay, so if we look at the second example. Okay, so again we have ratings 1 2 2. Okay, 1 2 and 2. Okay, again we will have an integer array equals to the size of rating. Okay, so we will at least one candy. For the first condition we will have 1 1 and 1 for each child. Okay, now we will check for the second condition. So like 1 is not having higher number of rating than its second index, so it will not be considered for higher number of candies. Okay, now for this first index we will have it is greater than the previous one, its neighbor. Okay, so it will have higher number of candies. So higher number of candies can be any, like we can have 2 3 4 5 6, but what we have to return the minimum number of candies. Okay, so we will give him one extra candy, so it will be 2. Okay, now in this case it contains the S scenario, like if we have 2 and 2, मतलब we have same equal value for two indices. ठीक है? So in that case, for this third index, what we can do, it is not greater than the previous, it should be greater than its neighbor, but it is not greater, so it will be not considered. Okay, so our final answer will be 4 candies will be required in this case. 4 candies is required in this case. Okay, so now I think we have understood the question. Now let's consider some scenario. Okay, so in case if we are having equal number of candies, okay, like if case 5, if equal number of ratings 5, 5, 5 and 5, if we are having equal number of rating, in this case what we will do, what will be the answer? So basically we would have an initial array equals to the size of rating, which will contain 1 1 1, at least one candy. Okay, now we will check from here, from starting to end, whether it is greater than the neighbor. No, it is not greater than the neighbor. It is greater than the neighbor. No, it is not. It is also not. It is also not. So all, in this case, what answer we will have, each child will have equal rating, that is 1. So 4 candies will be required in total to distribute among these children. So if in case of equality, what we will do, we will in case of equality, there is no rating, no child will have rating greater than its neighbor. Okay, so in that case they will have the minimum at least one candy. Okay, so this now another scenario that we have to check. Okay, so now in case we are having ratings in increasing order, so like it will have 1 2 3 and consider it 4. Okay, so now if we will check from here, so initially starting again we will have 1 2 3, okay, 4. So we will have one candy for the at least, or the minimum one candy we will have. Okay, now we will start from here. We will check whether it is greater than 1. No, it is not greater than the first index. Okay, so now we will check for this one. So is it greater than the its neighbor? Yes, it is greater than its previous neighbor. So we will increment it, we will give extra candy to this, so it will be 2 instead of 1, it will be 2. Okay, now we will check for this whether it is greater than its previous neighbor. Yes, it is greater than its previous neighbor. So what we will do, we will have to give the higher number of candy to this one. So what we will do, to the previous neighbor, to the candies of the previous neighbor, we will add 1, so it will have 3 candies. Okay, now again we will check for the fourth one. So it is also greater than its previous neighbor, so it should have, like according to the rating, like if rating goes high, then the number of candidates should also go high. If our rating is going in this way, then our rating will also go in this way. Like if it is 1 and it is 2, it is 3, so our rating, our number of candidates would also be increased in this way, because for the each, as it is given, for each child with higher rating gets more candies than its neighbor. So if it is having higher rating of 2, so it is having rating greater than its previous neighbor. So whatever the candies this child have, so we should have greater number of candies than this child. Okay, so in this way we are checking this. So this 4 is also greater than its previous neighbor, so it should also have greater candies than its previous child. So previous child was having 3 candies, so how many he will have? He will have extra 1 from its previous child, so it will have 4 candies. So in this way, 4 plus 3 7 and 10 candies is the answer for this, is in this case, if we are having candies in increasing order. So again, now one more case, the last case. What if we are having candies in decreasing order? Okay, so like in this case, consider 5 4 3 and 2. Okay, so again we will have an array equals to the size of rating. Okay, 1 and minimum 1 1 1 1. Okay, so now 5, so it is greater than its next neighbor. Okay, so it should have greater candies than this one, but we don't know how many candies it should have, because in case of increasing order, we know, like after 1 2 will come, or the next number would be greater than the previous number, so we can give greater number of candies from the previous candies we have given to the student. Okay, but in this case, when we are having decreasing, we don't know, like the next neighbor, or the current child current rating is how much greater than its next rating. Okay, so like in this case, if we are having 5 here, and we are giving, okay, 5 is greater than its next neighbor, so we should have a greater number of candies for this case. So for instead of 1, we will give 2. Okay, so when we will check for this one, so it is also greater than the next neighbor, so it should also have 2. But this is not the case because we already have encountered this in the question, like child with higher rating get more candies than its neighbor. So it is having rating of 4, it is having rating of 5, so obviously this child should have more number of candies than its next child. Okay, so in this case what we will do, we will start traversing from backward. Okay, so initially we will have 1 1. Okay, so we will start traversing from backward, so it is smaller than the its previous neighbor, so it will not have, but it is greater than its next neighbor, so it will obviously have greater number of candies from its previous neighbor. Okay, so it is also greater than its previous neighbor, so it should also have greater candies from its previous neighbor, so it will have 3. Okay, so it is now the last index, or the first index we can say, it is greater than its next neighbor, so it will also have greater number of candies than its previous neighbor, so it should also have 4. So this is our required solution. Okay, so basically for this solution what we are doing, we are traversing one in a forward direction, one we are traversing in a backward direction, and then one loop for counting or total of this our extra space, or we can say candies, for each student. Okay, so I think we have covered all the scenarios, and I think we have understood pretty well what the question required or what the solution should be. Okay, so what we will do, we now let first of all let's rub this and have, when we have mixed of ratings, like 4 3 5 2 and 6. Okay, now in this case what we will do, first of all we will traverse 1 2 3 4 5. Okay, 1 2 3 4 5. Initially we will have 1 1 1 1 1 1. Okay, so what we will do, first we will traverse from here, and we will have these candies according to the forward iteration. Okay, then we will iterate it from backward, and we will update the value in the same array. Okay, so like let's say it's a candy array. Okay, so moving forward, in forward iteration, what we are doing, we are checking if the previous element is smaller than, if the next element is greater than its previous one. Okay, so we will check for that. So if it is greater than, if 3 is greater than its previous one, no, it is not. If 5 is greater than its previous element, yes. So it will have greater rating than its previous one. So 3 is having 1, so it will have 2 rating. Okay, so now we will check for 2. If 2 is having greater rating than the previous one, no, it is not having. So we will have the last, we will move to last element. So is 6 is if last element is greater than greater rating than the previous one, yes it is. So we will again increment it by 1. Okay, its previous rating. So it will have 2. Now we have traversed it forward, now we will move from backward. Okay, now we will check if the previous element is having greater rating than the current element. Okay, so in this case 2 is not greater than 6, so no, it will not be the case. Now if in, we will check for this, 5 is having is 5 is so in this case, like 5 is greater than 2, so again we will have its value incremented, so it should have candies greater than its previous one. So it is 1 and it is 2, so already it is having 2, so we will not change its value. Now we will check for 3. So is it having greater value than the previous one? No, it is not. Now we will check for this one, 4 1. So it is whether it is having greater value, greater rating than its previous one. Yet yes it is. So what we will do, we will have greater number of candies for this one, so we will have 2 here, from greater number of candies from his previous one. So total is 2, 2 4 6 8. So 8 candies will be required in this case. So now we have looked for the solution. So now let's have an implementation of this. So first of all what we will have, we will have vector. Okay, first of all let's have size separately in a variable, int n is equals to rating size. Okay, now vector of int, let's say candy by candy, candy count is equals to n, and we can initialize it with 1. Okay, so now for the forward iteration. Okay, so int I is equals to, we will start by 1, because in the forward iteration now in forward iteration what we will have, we don't have the previous one. okay, and we have to check whether it is this one is greater than its previous one. Okay, so we will start from first index. I is less than n I plus plus. So what we will do, we will check if RATINGS ratings of I is greater than RATINGS ratings of I minus 1, then in this case what we will have candy count of I is equals to CAND by candy count of I minus 1, its previous one I minus, because we, if it is greater than previous one, then we have to have candies more than the previous one. Okay, so it will be the case. Now for the backward, for in this case we will start from n minus 1, because for the last element we won't have any element further to compare. So we will have n is equals to n minus 2, and I is greater than or equals to 0 I minus minus. Okay, so here we will check if RATINGS ratings of I. Okay, now what we are checking here, rating of current is greater than the previous one. Okay, so is rating of I is greater than RATINGS ratings of I plus 1. In this case what we will do now, okay, so consider this case, we are having a rating and we are having initial count as 1111. Now we will check if 5 is greater than 3, yes, so it will have true rating, greater candy than the previous one. Now 6 is greater than 5, so it will also have greater candy than previous one, so it will be 3. Now 2 is not greater than the previous one, so it will remain as it is. Now we, in the forward iteration we have got this count. In backward iteration what we will do, again we will start. So 6 is greater than 2, yes, it is greater than 2. So what should have, it should have a candy greater than the previous one, so it should be 2. So if we are not checking, so if in backward iteration what we will do, we will overlap the original value, like it should have the 3 value, but if we don't check and we will not find the maximum between the previous value which is already there and current value which is generating, so we have to give the maximum of these two. Okay, so otherwise it would be wrong answer, because if we move backward now, so if 6 is greater than 2, so it should have rating candy greater than the previous one. So previous is having 1, so 1 plus 1 it would be 2 in the backward, and in forward it is having 3. So obviously 3 is the required answer, because in forward iteration it is greater than the 2 ratings previously. Okay, so we will have maximum of CAND by candy count of I is equals to maximum of CAND by candy count of I comma CARA. Okay, CAND by candy count of I plus 1 plus 1. Okay, now we have a calculator of forward and backward. Now we need to find the sum. Okay, so we can have here integer answer, int answer is equals to 0 is equals to m. Basically we can have, or is equals to 0 because already we are calculating, we have initialized. Int I is equals to 0, I is less than n I plus plus. So we got en as wr answer plus is equals to CAND by candy count of I, and what we will return, RET will return ANSWR answer. So first we will run this. Okay, it is now, let's submit. Submitted successfully. Now to for the time complexity, as we are iterating, we are using having 3 loops, but we are iterating the rating linearly, so its time complexity will be capital O of n, where n is the size of this rating array. So this is the solution. Thank you for watching.